Okay, so if you go to Google and then you can Google for string Java API, that's what you can do. If you go to the API page for the string method, string class there, you can see over there all the information there, something you can read. And also you can see that there is a method there called append. Okay, I'm going to go there and show that to you. Okay, it's a bit too. I think I remember that wrongly. Okay. Okay. So this is a class I want you to look at. Sorry. So this is a class. So it's called string buffer. Okay. So this class in some ways is more useful than string, but you can feel free to use it if you like to. Okay. This is something I didn't talk about in class, so this will be the first time to introduce that. So the class is called string buffer, and you might find it useful also for your assignment too. Okay. It's called string buffer. Okay. Let me show you how to use it. The string buffer is like a class, and then it has several constructors here. So typically, you would just use the this version of the constructor, where you will simply just initialize like an empty string buffer. And the useful method you want to have is something called append. You can append a string, you can append a character, you can append a boolean. Okay, so let me show you how to use it. So now in this case, let's say we would like to have a string buffer. Let's say string buffer here is equal to new string buffer. Okay, just like a normal class. So this will initialize a new string buffer empty. And then you would say string buffer dot append. Okay, let's say append the first line. So you would say x coordinate value and then colon and then x. That's the first line. And now you want to put a new line in between. So string buffer dot append and then the new line here. And then you will do the second line, which would be very similar to the first line. So you would say y coordinate value here and then plus the value of y. And finally, you will simply say string buffer dot toString. So basically you can see string buffer is also a class. And of course, object is also its superclass. That's why the string buffer also has a toString method. So we are trying to append different strings into the string buffer. And eventually, we just want to return what we have appended so far. That's why we call it toString method. Just another way to use it. Okay. Let's try that and make sure that works. If you go to run the code again, you can see for the first one, it says x coordinate value 2.0, y coordinate value 3.0. Okay, that works. And then for the second print statement, it also prints the same. So that seems to work. So the code over here is equivalent to, let's say if you didn't want to use string buffer, that's fine. If you didn't want to use it, then you should write something like this. You'd say string s is equal to, okay, you can say x coordinate value here plus x plus a new line and plus y coordinate value and plus y. And then after that, you just return s. That will also work. So I'll just put this in comments. So sometimes you may not just want to do plus and like a one line, expression. So you may want to just have some object here and then just keep appending strings into it. So just two different ways to do things. Okay, you should know both. Okay, I would say you might find the second, the approach I just commented out might be more useful to your assignment too. But the first approach might be more familiar to you. Okay? Both will work. Any questions about toString method? Okay, so now the first lesson for you to learn was whenever you want to change the way you want to print the objects from the system and out the print line, you should redefine the toString method appropriately. Okay. Now let's do something else. If you go to the point tester here, and let's say we do system, let me just comment this out, okay? Because these two lines are really just equivalents, okay? So system.out.println. let's say P1 equals P2. So what should be the value for this? P1 equals P2. False. Why? What does equals do? The addresses value and compare to see if they are the same objects. Apparently they are not, because P1 and P2 are created from two different objects using the new keyword, so they are different. So if you do that, P1 equals P2 will give you false. Okay, that's not surprising. Let's do another one. Since we said whenever you want to compare contents, you have to use the equals method. So you would say system.out.println P1 P2. And it seems like it should be true, but because P1 is at location 2, 3, P2 seems to be at the same location. But now, when I say P1 equals P2, what will be the result? True, false, true, false. Okay. Why false? Why false?
The equals method.
In the point class, and maybe that's something you're missing. That's okay. We're gonna see. Okay. Let me just to avoid confusion. Let me just comment out the print line here. Okay, so we can concentrate. Only print out this line here, and let's see if that's true or false. False. Even though you're using the equals method to compare P1 and P2, it doesn't seem to have compared the contents of the 2 points. Why? Let's find out why. How did you find out? Use the breakpoints and debugger. So let's put a debugger here at line 11 here, and we'll walk into the equals method to see how it does the comparison, so we can find out why it didn't compare the contents. So you can say run as Java application. Oh, sorry, debug. Run debug as Java application. And then it shows, okay, now we pause at line 11, right before we try to print out P1 equals P2, right? So you would say step into, and you can see you step into the equals method in the object class. You see, because this equals method is already defined in the object class, and object class is a superclass of every class. Since we haven't done anything about this equals method in the point class, that is why when we call the equals method, you will actually reuse the definition that is inherited from the object class. And you can see what's there. As I put on the lecture notes, it simply returns if this object here, which is P1, equals object in the argument, which is P2. It simply compared and using equals. So this is the inherited version from the object class. Salman, follow? Good. Okay, that's why even though you use the equals method, it will still give you false. So the way to fix this is we have to redefine the equals method in the point class. Okay, like we had to redefine the toString method in the point class. Let's try to do that. If you say stop and switch to Java perspective, so let's go to the point class, and now we're going to say if you type equals something like that and do that, you can see again we have the override comment here, which means this is actually inherited from the object class, and we are trying to redefine that or to override that. So now, how should we define that? And also we should change the signature here. So every time if you want to define the equals method inside a class, you should really change the type to a point. Okay. Okay, so now how should we define that? So 2 points should be equal if their x and y values are equal, right? So, yeah. So let's do a one line implementation. You can say return this dot x equals. That's fine because they are double values. Equals. Well, if you don't like the name obj, you can change it to other. I prefer other really. Okay. So you can say other dot x. And now, somehow we should say it should be that the x values are equal and the y values are equal. So that's why we should use conjunction here. And also this dot y equals other dot y. This is the simplest one you can write. Okay. And let's see what's wrong here. Maybe. Okay, just remove the override. So I would say every time when you have override the Eclipse, just remove that. Somehow it's causing the trouble. I'm not sure why. Okay, that's what you should do. Okay, this is simplest implementation you can have. I will show you a slightly more indirect way of doing it, which might be more understandable. But let's say we do that, and then let's try to run the debugger again. So this time you will see that if we step into the print statements, it's going to call this version of the equals rather than the equals method from the object class. Okay. So if you go to the point tester and then run debug as Java application. Again, we pause here. If you say step into, so this time you see we are now in the equals method, not in the version of the object class, but now we are in the version that we just redefined. So Java has a way to actually find out what's the latest redefined version of your equals method or toString method, which is something I will talk about also on Friday. It's something called dynamic binding, which wouldn't make sense to you right now, but that's something I will talk about on Friday. Okay, so it seems like it is going to call this version of the equals method, which indeed does compare the contents of the two objects. And then if you try to run that, and it's going to return true to you. You can see it's true over here, right? So let me just try to run it again. You'll see true, right? So this is lesson number 2 for you. Whenever you want to compare objects by contents, you have to redefine or to override the equals method in the objects class, right? That's second lesson. Okay. Yes.
If you don't redefine, then it's going to compare the objects, not the contents of the objects, right?
It's going to, yeah, as I showed you before. So let me show you again because it's really important. Let's say if you didn't do that, let me just comment this out. So now it's as if we didn't do it, right? If you do that, and now if you try to run the debugger again, then let's see which version of the equals method will be called. So if you do run debug as Java application, so now if you step into it, you will see that the version of the equals method that's called is in the object class. And this one simply use the equals. I think comparing addresses like location.
Name isn't the name of the
like addresses.
Comparing P1 and P2.
Huh?
If the names are the same.
If the names are the same. No, not the name. I mean like addresses. Think about if they refer to different objects. If they refer to different objects, of course equals will give you false. So this and object, they are like references, like addresses to the objects. If they belong to different objects, of course they will give you false. Are we good?
Yes.
Good.
So this will give true only if
they refer to the same objects.
Same object.
Yeah. Yes. Okay, so that's the default version, which I also included in the slides. So when you study the note, you will also see that. So this may be satisfactory to you, but it may not be. When it is not satisfactory to you, you should really redefine that in your class. Okay, that's the lesson. Okay, so now stop and then go back to Java. And now let's see. Let me just go back to this. So somehow the toString method and equals method, they can help each other in the sense that once you decide what should be the way to define an object, so here we simply say x coordinate value will be some x and y coordinate value will be y. So maybe it makes sense to say, well, two objects or 2 points will be considered as equal if their string representations are equal, right? Because somehow you include all the important, you actually include all the important information in the string representation, which is x and y. If their string representations are equal, then of course the object should be equal by contents. So very often, you can simply say the following. So rather than saying this.x equals other.x, you can say this dot toString equals other.toString. This will also work. So you can see somehow this.toString is going to return back to you a string, which contains the x and y values as part of the string. Other toString is also going to contain the x and y values for other in the string. Somehow, if these two strings are equal, that means the x and y for both objects are equal. Okay, so this assumes that you actually define your toString method properly. If you haven't, of course, this is not going to work. I'm just showing you two different ways. Okay, I'm going to write it down. So version 1 define equals in terms of attributes, in which case you would say return this dot x equals this dot other dot x, and this dot y equals other dot y. That's version 1, but I'm going to comment that out. And version 2 define equals in terms of the return values of toString. And we are making one assumption here. Assumption, the toString method has been properly overridden, which means has been properly redefined. Yes?
We don't have the toString method. In that case, can we compare by these dot
toString?
equals other?
No. Then no.
Isn't it supposed to compare the contents too?
So we say that again. So if you don't have the equals method there, redefine.
And then we use these dot equals bracket other.
If you haven't done that, then you will simply call the version that's inherited from the object class, as I show you. Yeah. So the rule is simple. If you didn't redefine the toString method, then it is going to reuse the version that's inherited from the object class. If you didn't redefine the equals method that is inherited from the object class, then it is going to use that version. Okay, the version that you latest redefine will be used always. Yeah, so Java has a way to tell that. Okay. Okay. So now, if you just go back to point tester here, and let's try that. If you say p1 dot equals p2, if you do that, it's going to give you true because we have properly defined that already. Okay. So now let me do one more thing for you. So if you put a breakpoint here, if you say run debug as Java application, and now you can see that system.out.println dot equals. Let's walk into it. So now you can see that. Now we are in the point class in the equals method, right? Equals method for the point class. You can see somehow it is going to call the toString method, right? So if you walk into it, so first of all, this .toString is going to call the p1 .toString, right? And if you step into it, you can see this is toString method. So it is going to construct a string for you. So if you go to the end, you can see that what s is. So now you can go to expression here, and you can type s. You can see s here is simply yeah, you can read it maybe better on your screen. So it says x coordinate value 2.0, new line, y coordinate value 3.0. Okay, and let's go further. So we have just seen this .toString. Okay, let's go further. So now we are having other .toString, which is p2.toString. And then we just go step over again. And then let's see what s is this time. So it's again x coordinate value 2.0, new line, y coordinate value 3.0. So they are indeed the same string. Okay, and then it's going to return back to you true. That's why you will get true over here. Okay, so you should really try to repeat the exercise yourself to make sure you really understand what's going on here. Any questions about the point class? Nope. Okay, let's do a slightly more complicated exercise, which I also talk about in class. Let's do rectangle and rectangle collector. Okay. Let's do one step at a time. Let's create a new class called rectangle. if you go back to your Project Explorer, and let's create a new class there. Just call that rectangle. Okay, rectangle there. Let's say for rectangle, we simply have two attributes. Let's say double, let's say length, and also double width. And let's have one constructor there. Let's say rectangle here, and then you will have double length and double width. So you would say this dot length equals length, and this dot width equals width. Okay, should be easy here. So now, if you just go back to your package explorer there, and then let's have a new class there called rectangle tester. Let's say rectangle tester. If you do that, and also create a main method there, and now if you say rectangle R1 equals new rectangle, and then what about we'd say 3 and 6. Rectangle R2 equals new rectangle, let's say 2 and 9, let's say. It seems like, although their width and length are different, but their areas are the same. And let's now try. System.out.println. You can say, let's say R1 equals R2. We know very well, because R1 and R2 are different objects, so this should be false. If you say system.out.println R1 equals R2, what should be the value for line number 8?
False.
False? Why?
You didn't declare.
You haven't redefined. You haven't overridden the equals method, right? So let's verify that. That was correct. So both are false. So now what I would like you to do is to solve this problem here by changing the rectangle class. Okay, give you a few minutes to do this. What should you do? You should know. Sure. Okay, so now you should change the modify the rectangle class in such a way that line number 8 in the tester will return true. Because two rectangles should be considered as equal if they have the same area, even though they have different lengths and widths. Okay, that's an exercise for you. I'll give you maybe 3 minutes to do it. Should be very easy. No? Did you actually follow the point example? Yeah, if not, then you may have to watch the recording later to make sure you follow. Yeah, it's actually quite basic. Yeah. So see what you did in the point clause in order to solve that issue, and the issue in rectangle should be solved in the same way. Okay, another minutes before we go over a solution. Huh? Yeah. Okay. Any clue? Kind of. Very good. You should be, oh, very good. Compare the area. And what's the type of two areas? They're simply just double. So to compare double values, you can use the equals. You want to return a Boolean value, which would be evaluated by comparing the two double values. Okay, let's go over the solution now, and it should be very easy. Let me do this slightly more wordy way, but it actually shows you what should be the thinking process. If you go back to a rectangle here, first of all, we want to redefine the equals method. That's the solution, first of all. So you say Boolean equals, and then you should really write the same name as a class, other, okay? So now that means we are trying to overwrite or to redefine. So now the idea is we should calculate the area for the current rectangle and calculate the area for other rectangle and compare to see if they are equal. So you can see double, let's say double, let's say area 1 equals this dot length multiplied by this dot width. This keyword here is not really necessary, but I just wrote them so kind of emphasize we are really trying to do the current rectangle. And area 2 would be 2 is equal to other dot length multiplied by other dot width. Okay?
Just with one line of code.
Yeah, I can do that. I just want to show you, Yeah, because for other people, this might be easier for them. So now, somehow we'd like to see if the areas are equal. So we can say some Boolean variable here, Boolean areas are equal. Is simply assigned to area 1 equals area 2, right? So you can put a parenthesis here if that help you. Finally, you can say return the areas are equal. Okay? Of course, you can do it all of this in one line. It's possible. I'll show you the one line as well. But this really shows you the thinking process. Calculate the areas individually and compare them, get a Boolean value, and then return the Boolean value. Okay? And I'm going to put this in comments and show you the one line version. If you want to do it in one line, it's also easy. So you can say, yeah, you can simply say return this dot length multiply this dot width equals, and then other dot length multiply other dot width. This also works. However, another better solution would be because the area calculation should be a very common routine that you want to apply. You want to ask about any rectangle. So it's certainly worth defining a separate method for that to actually get an area. So what you can do is you can define another method here which will return a double. Get area of the current rectangle, and then you would say return this dot length multiply this dot width. Okay, do that, and now you can reuse the code already. So you can say the following. Okay, I'll also comment this out. So now I'm presenting another version. Okay, which version to use is really up to you. Okay, so another version would be you can say return this dot get area equals. This will also work because somehow you can avoid the trouble of saying the multiplication twice. In some way, you're also repeating the code. But now if you just call the same method, it will also do the job. Okay? Any question about this to redefine the equals method? No? Comment? Are we good? Good.
I don't have to put public Boolean, right?
Don't worry about public, actually. That's something maybe I'll talk in the last lecture. I don't think that's important for this course. Really. Okay, so equals here. And let's try another thing here. Let's go to the rectangle tester here. And then let's say I would like to print out system.out.println. And then let's say simply say R1. And also I have R2. Okay, so now if you do if you do that, you can see that it simply print out the addresses for the two rectangles. But that's not something I want. What I want is, I would like to say something like this. You can say rectangle has width, let's say 2.0, and length 9.0, something like that. And okay, let me just have another line. And rectangle has an area of 18.0. Okay, you know what? This is what I want. Let's say this should be the string representation I want. Okay, let's say this is the, I would like the string system out of print line to give me something like this. Something like this rather than something like this, the addresses. How do you do that? Rectangle has an area of something, and that's calculated based on the width of something and length of something, right? How do we do that?
Define the toString.
But how do you redefine that? I'll give you a few minutes to do this exercise. It's very similar to how you print the locations for a point, right? Okay, this should be very easy to do. Okay, give you another minute, and then we'll go over the solution. And then we'll move on to rectangle collector. Include? Okay. Nothing good. You may have to walk through the example more carefully. Include? Okay. Include? No? Let's see. Yeah, so if you still are confused, I think you better go over the recording for today. Okay. So somehow toString method and equals method, they are very easy. Don't think they're too complicated. You know, very easy ideas. They're not complicated. Okay, let's see the solution for now. Almost done? Okay, that's okay. So let's go over the solution now. So in order to make sure you can print out the string representation properly, you have to redefine or to override the toString method. So let's go to rectangle class, and then we have to redefine the toString method. So toString method returns a string. So toString here takes no input arguments. And now we'll say return. Let's say do a one-line implementation. Let's say return. So you can say rectangle has area. Let's say has area. And now what's the value of the area? You can say this dot get area will give you the value. And then you can say open parenthesis plus. So you want to do the length plus and then length. And then I'm going to separate that in a moment. And then and width plus, okay, maybe better put a space here, and width. Okay, I'm going to separate it.
Not necessary, right? Like this keyword there.
Yeah, no, it's not necessary. Yeah, I just put it there, but it's not necessary. Okay, length, and then we have the width. Okay. Okay, something like that. Okay. Of course, you can use a string buffer if you like. Maybe I'll show you the string buffer version as well. Okay. So I will show you in a moment. Okay, toString method here. Yeah, let's say public. No, I don't think so. Oh, really? Okay. So somehow you have to put public here. So just to, yeah, it's a bit ugly. So you don't have to understand why there should be a public in front, but just put the public here. I better talk about the visibility issue, okay? But let's say in the quiz or in the test, if you forgot about the public, that's fine. But when you do the assignments,
like error sometimes, so I just put public.
yeah, I would rather talk about the modifiers maybe at the end of the course. Yeah, I don't want to confuse you guys too much. Okay.
Professor, today's lab will be included on Friday's piece.
Today, no, not today, but it will be up to Monday and Tuesday. Yes. Yes. But certainly you want to understand these well, right? Yeah, maybe not so urgently. Okay, so now let's try the string buffer version. Okay, so what you can do is to say string buffer and then sb equals new, initialize an empty one, string buffer, that's an empty one, sb dot append, very good, first line.
Just code point.
Yeah, rectangle has area and plus this dot, yeah, you don't have to say this, so I can say get area, and then you can say, oh yeah, you're right, append only. Append, and now we're going to say length plus comma, and then sb the append. There should be no new line in between, so that's why I didn't put any slash n. Okay, so it would say width plus the width, and maybe plus some close parentheses. Okay, so I can put the original one into comments. And eventually, you can say, as I show in the point example, so you can say return sb.toString. Okay, let's go back to rectangle tester here, and then we can now do run again. So you can see now we do have the correct formats. Rectangle has area 18.0, one is with length 3.0 and width 6.0. The other one is with 2.0 and width 9.0. Good? Now, I got a small challenge for you, okay? So now we agree that, okay, now be careful here. We define the equality in between two rectangles to be two rectangles are equal as long as their areas are equal, even though their width and length may not be equal. Okay, that's how we define equality between rectangles. So now, tell me if this will work. So let me comment this out because we got a possible version 4. Can I say return this dot toString dot equals other dot toString? Can I or can I not? Remember what we said in English. We said two rectangles are equal as long as their areas are equal. But now I'm trying to redefine the equals method by comparing the toString return values of the two rectangles. Is this going to work or it is not going to work? Okay, I'm waiting for the answer.
It will work.
Huh?
I think it will work.
Yes or no?
Yes. Yes. You
think yes? So you think it's going to, if I say R1 dot equals R2, it's going to give me true or false? You think that's true?
I don't know, maybe.
Okay, it's very important to think about this question here. It's not so hard. So now let's try that. So let me just isolate that. So now let me put this into comments. And I just want to print out R1 dot equals R2. It gives me false, actually. But why does it give me false? Since like the two rectangles have the same area, but why the dot equals method will give me false? Why?
Oh, because the values are different.
Because you can see somehow if you go back to rectangle class, and if you see the toString method there, you can see to define the toString, not only that we include the information about the area,
Yeah,
we also
everything has to be
include
the same, right?
this part of the string is the same. However, you can see the remaining part of the string would not be the same because we also include the individual length and width. So this is the case where, so that's what I said, often you can use the toString method to define your dot equals method, but not always. So this is the case where you're including way too much information, or you somehow the definition for toString simply cannot be used to redefine the equals method. So this is not the case to use it.
So if you just erase those two lines.
Well, it's up to you really. If you want to include the length and width, you can do that. It's just that you cannot reuse the toString method to redefine your equals method. Okay, so it's completely up to you. Okay, so I hope you guys pay attention to this, right? So it's very important exercise to understand. So why you cannot use the toString method in this case to redefine the equals method. Okay, if you didn't follow, watch the video when I post it on web. Okay, so we cannot use, so now I will put a comment for you. So cannot use toString to redefine equals in this case. Okay, but why? As I explained, you should really try to also understand yourself. Okay, so we're going to put back the original definition just to compare the area. Okay. Okay, now one more exercise. So now we're going to do another class here. So new class, let's say rectangle collector. New class here. And it's going to collect an array of rectangles. So it's going to say rectangle array rectangles. Okay, just one single attributes. And then we're going to say the following. So let's say in the constructor here, we say rectangle collector here, and then we're just going to initialize an array of size, let's say 20. Okay, so you can say rectangles equals new rectangle, and then let's say 20 here. Okay, let's do that. And let's also have the method here called add rectangle. So you can have void add rectangle here, rectangle R over here. And now you can actually try to do that. Seems like we need a counter, don't we? So we have to say integer number of rectangles, and you have to use that to assign to the right spot. So you say rectangles and number of rectangles equals R, and also number of rectangles plus plus. So this actually is the pattern that we have used over and over again. So you really should understand why we're using this pattern. Otherwise, you would be in big trouble for the final. Big trouble. Okay, so now what should we do now? So somehow, let's go back to the tester. Okay, I'll just reuse the rectangle tester here, so you don't need a new class. So we got R1 and R2. So I'll just comment out the print line. Okay, you can comment them out later. So let's say we have a new rectangle collector here. So let's say RC, our rectangle collector, equals new rectangle collector, maybe RC1, we need 2. And also we have rectangle collector 2. And after that, we'd say RC1 dot add rectangle and R1, and also RC1 dot add rectangle R2. So we're adding R1 first and then R2. Okay. And now we're doing another one. Let's say we're doing RC1 dot RC2 dot add rectangle. Let's say we add R2 first. And RC2 dot add rectangle R1. So now for both rectangle collectors, they both contain R1 and R2, but somehow the order is different. So for RC1, it contains R1 and then R2. For RC2, it contains R2 and then R1. But let's make the following definition. two rectangle collectors are considered equal if you compare position by position their rectangles. If their rectangles they contain are equal, then if all of them are equal, then the rectangle collectors are equal. So in this case, you are supposed to compare R1 with R2. And R1 is equal to R2 according to our definition because they got the same area, even though their length and width are not the same. And also R2 and R1, although their length and width are different, but their areas are the same. So they should also be considered as equal. So now you can see the first position and the second position, the rectangles are all equal. So now we should really get true when we say RC1 that equals RC2. Okay. So now let's try that. Again, you should really try two things. System.out.println RC1 equals RC2. And this will give us false for sure because we're talking about two different rectangle collectors. If you do system.out.println and then RC1 dot equals RC2, should that be true or false? Why false?
Comparing RC1 object with RC2.
Because we haven't redefined the equals method, right? Very good, very good. So now, your job, redefine the equals method in rectangle collector in such a way that it's going to compare, it's going to give you true only if all the rectangles in the two collectors are equal. Okay, I'll leave that to you. Okay, I'll give you maybe a few minutes to do this, and then I'll give you a solution, and then we are done for today. Try a few minutes. You certainly need a loop. Mm-hmm. I believe this code is also available in the slide, so you can also check. But I think it's better you also do a lab exercise like this, so you can have you can emphasize the point actually. Okay, try that. We have to redefine the equals method in the rectangle collector class, such that it's going to compare the areas of the rectangles one by one. If they are all equal, then of course the rectangle collectors are equal. Otherwise, they are false. Do you need any extra help, honestly? Yeah, if you need extra help, you really need to come to help. You want to help me tomorrow? Not worry about because I'm suffer from the basics. So we can talk about it since I'm going to defect the regency right? Good. Even tomorrow. Tomorrow. Oh, that's okay. Yeah, that's fine. That's fine. Okay, give you a few more minutes and we'll walk through a solution together. Okay. And Harvard, hopefully you'll find that our tutorial session today help you do this loop.
Wait, you're trying to compare the entire array, the two arrays, right?
You're trying to compare
RC1 collector and RC2 collector. What's inside of it?
Yes.
Alright.
Now when you define that, when you define this equals method in the rectangle collector, you don't really have RC1, RC2. You only have this and other, right? RC1 and RC2 are when you are using them. But when you're trying to define the methods, you only have this and other. Yeah. Give you another 2 minutes, and then try to do as much as you can, and then we'll go over the solution. Okay, let's have a look together. Okay. So actually, we have seen such loop for a long time. So it's really about a combination of the loop and also how you use the dot notation for navigating the object path. So if you go back to rectangle collector here, so first of all, we have to redefine the equals method. So we're going to say, just say public here, and boolean equals, and then you would say rectangle collector, and then let's say other. So in this case, because we're going to compare 2 arrays, so it'll be easier for us if we can assume the arrays are of the same size.
Yeah.
But to actually filter out the cases where they are not. So you can say, first of all, we can say if it is the case that rectangles, let's say this, just to emphasize, this dot rectangles dot length is equal to other dot rectangles dot length. Okay, you can see we are using many dots here. Okay, if that's the case, then we can do further comparison. Otherwise, if they are simply just not of the same length, and there's no way they got the same number of rectangles, right? Oh, actually, you know what? This is not right. You should really say the following. You should say this dot number of rectangles rather than length, because the length is going to be the same, just 20. You should really test the counter. Okay, that's the trick. So other dot number of rectangles. Okay, that's what you should do. If they contain the same number of rectangles, then you will bother to look further. Otherwise, you will just be false. Okay, and then you would say you can simply just let me do it better. So let's say boolean. Let me do return false. Okay. So now for this branch over here, we're going to do further comparison. Okay. So now we're going to do the following. So say for integer I equals 0, I less than number of rectangles, and I plus plus. Okay. That's something very routine. And now, how do we know if the rectangles contained in the same position in both rectangle collectors are the same? The way to do that would be you have to say if. So let's say, let me do the following. So now in this case, let's have a Boolean variable here. Okay, let's say all rectangles are equal. Okay, that's simply true. Okay.
You put that inside a full loop, right?
No, actually outside the for loop. You just want to initialize to be something, and then whenever you find any unmatching, unequal rectangles, you have to set it to false. That's sort of the idea. So you would say if it is the case that the current rectangles we're looking at, which would be this dot rectangles I dot equals, so we're calling the equals method in rectangle, which will give us the area comparison, right? So that's why we had to define the equals method in the rectangle class, which we did already. Dot equals, and then other dot rectangles I. If this is the case, then certainly all rectangles are equal should remain true. If this is not the case, so exclamation mark to negate the result. If this is not the case, then you should set it to false. Then you should set it to false. Okay, so we're going to run through all the rectangles. Okay, and after that, we're going to return if all the rectangles are equal. Okay, so this is certainly one way to actually do this. Okay, I hope that's straightforward enough. If you find another way to do it, you're not sure if that works, you can talk to me. Okay, later. So basically, we're trying to maintain a Boolean variable called all rectangles are equal, and we're going to set this Boolean variable to be false as soon as we find out there are any rectangles at a particular position are not equal between the two collectors. Okay, that's how we do it. So now if you go back to the rectangle tester here and try to test to see if RC1 equals RC2, you'll find that it's going to be true rather than false. Okay, so that's maybe this might be this most complicated method for today. Okay, but it's not too bad. That's what you should do, just to redefine the equals method. Any questions about the equals and toString methods? So we actually have done quite a number of exercises today on the two methods. So please review the all the solutions and follow the video again if you find it necessary. And although this won't be in this Friday's quiz, but it might be in the final or in next week's quiz. Okay, no way around. It's gotta appear at some point. Okay, if you have no questions here, then that'll be it. And then I got your midterm paper. I'm going to return back to you now.